Your API shouldn't block while it resizes images, sends emails, or calls a slow third party. Today we build a background job pipeline end-to-end using Azure Functions and Azure Service Bus queues. By the end, you'll know the architecture, the exact wiring, the retry and poison message handling, and what to check when it's live. The pattern is simple. The web app drops a message on a queue and returns immediately, and a function processes that work asynchronously. Let's build it so you could recreate it from memory. Here's the shape. A client calls our producer, an HTTP triggered function or web app, which serializes the job and sends it to a service bus queue. The queue durably stores the message. A second function with a service bus trigger picks it up, does the work, and writes results to storage or a database. Service bus gives us at least once delivery, automatic dead lettering, and ordered processing per session if you need it. Keep the producer and consumer as separate deployables so they scale and fail independently. Provision in order. First, create a service bus namespace and pick the standard tier or higher because Basic doesn't support topics or sessions. Then create the queue itself, setting max delivery count and lock duration. Next, create the function app, ideally on the premium or flex consumption plan if you want VNet integration and no code starts for steady throughput. Finally, store your connection details in Key Vault rather than app settings. Here's the queue in Bicep with the two settings that matter most for reliability. The consumer is where the magic is. With the service bus trigger, the function's runtime manages receiving, lock renewal, and completion for you. When your function returns successfully, the message is automatically completed and removed. If it throws, the lock is released and the message is redelivered. Use the modern SDK binding and accept the message and a message actions parameter, so you can dead letter explicitly when a payload is invalid and there's no point retrying. Notice we're binding by connection name, which resolves to your key vault-backed setting. Here's the decision that trips people up. Where do retries live? Service bus owns delivery retries. Each time your function throws, the delivery count increments, and once it passes max delivery count, the message goes to the dead letter sub-queue automatically. That's your poison message safety net. Don't bury work in an infinite in-process retry loop, because you'll hold the lock and starve throughput. Instead, let transient failures throw and be redelivered, and explicitly dead letter anything that can never succeed. Then monitor the dead letter queue and alert on its depth. Because delivery is at least once, your handler will occasionally see the same message twice, so make processing idempotent. Use the message ID or a business key to detect duplicates, or enable duplicate detection on the queue for a time window. For scaling, the function's runtime adds instances based on queue depth, and you cap concurrency with max concurrent calls in host.json. Set prefetch to reduce round trips for high-volume queues. If ordering matters, use sessions, but know that sessions serialize processing per session ID and reduce parallelism. Now confirm the whole path. Send a test message, then watch the consumer's application insights traces for an end-to-end correlation from HTTP request to completion. Check the queue's active message count drops to 0 and that the dead letter count stays at 0 under normal load. In the Azure portal, the service bus metrics blade shows incoming and outgoing messages and lock renewal failures. Throw a deliberate bad payload and confirm it lands in dead letter. Finally, load test and watch the function app scale out as queue depth climbs. To recap, the producer sends to a service bus queue. A service bus triggered function processes asynchronously. The platform handles retries and dead lettering, and you make handlers idempotent because delivery is at least once. The one takeaway to internalize: let service bus own retry and poison message handling through max delivery count and dead lettering rather than reinventing it in code. Tiers, plans, and binding extension versions change, so check the current Azure docs before you commit your configuration. Build this once and you'll reach for it constantly. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.